Welcome to the platform of Unacademy, India's largest online learning platform. Let me check the things. So, welcome you all. Good evening to everyone. Good evening Indrajit. Good evening Ashish. हेलो सभी का स्वागत है इस सेशन में कास्टिंग के पार्ट 2 सेशन में. I welcome you all to this session of the casting part 2 on the India's one of the best and greatest amazing platform that is an academy. तो चलिए, जो लोग मुझे नहीं जानते हैं, जो न्यू हैं, फॉर देम माय नेम इज विद्यापति कुमार and I have a 4+ year of teaching as well as R&D experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research papers of national and international repute. So, if you have a keen interest about the research works, feel free to Google about me and study my works. So, this is going to be your casting part 2. In the casting part 1, we have seen a lot of introductory things, basic terminologies, and this casting part 2 is basically this is going to be, it will cover the patterns, types of patterns, allowances, whatever the allowances we have talked, allowances, as well as this will all cover some miscellaneous topics, right? So you should download the Unacademy Learning app because Unacademy Learning app has various benefits for your preparation of GATE or for a preparation of ESE. So for both the preparations, there is a benefit if you download the Unacademy Learning app, because from Unacademy Learning app, there are two classes. First class is paid. Paid classes are there, and for the paid classes, that is plus subscription. If you take the plus subscription, then you will be able to do the paid classes, and there are the free classes. There are the free classes that are known as special classes, and in the special classes I am taking strength of material. I am taking strength of material at Unacademy Learning app, and let me tell you, for tomorrow and day after tomorrow, for the 2 days, I will be taking the strength of material at 9:30 a.m. Okay, I will be taking the strength of material for 9:30 a.m. Okay, so from 9:30 a.m. I am going to take the strength of material for tomorrow's and day after tomorrow's class. So there are the benefits like daily live classes are there, structured courses are there, live test and quizzes are there, and unlimited access of the materials are there, right? तो सर ये सब बेनिफिट्स हैं सर. और अगर आप प्लस सब्सक्रिप्शन लेना चाहते हैं, यू शुड गो फॉर द प्लस सब्सक्रिप्शन बिकॉज 100% complete coverage of all subjects would be there. So all subjects would be there. Okay, so this is the benefit of the plus subscription. 100% coverage of all the subjects would be there. Daily live classes are there. You will get the opportunity to interact with your educator, and your doubt clearing session would be there. बहुत doubt clearing session होगा सर, आपका कोई doubt नहीं बचना चाहिए. That's the goal. Live test and quizzes will be there, mock tests and everything is there. So these are the benefits. आप इसके साथ और क्या कर सकते हैं, आप वहां पर बहुत सारे एजुकेटर्स का कोर्स मटेरियल को देख सकते हैं, नॉट फॉर वन एजुकेटर. As well as if you want, you can make the personal coach to educator that is liable to help you throughout the preparation. Okay, so these are the top educators of the Unacademy, as well as Unacademy has for the GATE and ESE. Unacademy has a lot of batches, and for the different branches, it has the same course materials. So if you're planning for a plus subscription, you should go for a plus subscription. For a 12-month, it would cost around 25,000. But if you will use my code SIRVK, 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 then you will get a 10% off. 10% off in the amount. ओके, सो 10% ऑफ सर आपको मिलेगी, और वो कोड होगा सर VK, SIRVK. सर VK यूज करते हैं तो आपका 10% ऑफ मिलता है, और माई मेंटरशिप वुड ऑल्सो बी देयर विद यू. सर इसके साथ साथ क्या है, नेक्स्ट थिंग इज व्हाट, इफ यू आर प्लानिंग फॉर द 24 months, this will cost around 30,000. लेकिन sir, if you will use my code sir VK, then see the difference. You have to pay only 27,000. So I think investment on your career is very much important, and that's what is an academy subscription. Let me check. Good evening, Syam Babu. Good evening, Mayur. Good evening, Mukta. Duration of class will be same, sir. Yes, Ashish ji, duration of class will be same, but for the tomorrow and day after tomorrow, I have to take the classes at 9:30 a.m. morning. Okay, तो चलिए अब हम अपने discussions को start करते हैं. So yesterday what we have seen is shrinkage allowance, right? Shrinkage allowance हमने पढ़ा था. तो आज जो है हम पढ़ने जा रहे हैं मशीनिंग और फिनिश अलाउंस को. ठीक है, तो आज जो है हम पढ़ने जा रहे हैं मशीनिंग, या फिर उसका और एक नाम है फिनिश अलाउंस. ठीक है, तो चलिए, दिस इज गोइंग टू बी आवर द फर्स्ट टॉपिक. व्हाट वी हैव बीन सीइंग in the yesterday's class was the shrinkage allowance. Now machining or finish allowance. What is machining or finish allowance? Suppose when you have casting, right? When you did the casting, and from the casting you got, suppose like this. Okay, suppose this thing, like this type of casted product is being, ऐसा कुछ कास्टेड प्रोडक्ट जो है सर हमारा कास्टिंग के बाद मिल गया. तो सी यू कैन सी there are the surface finish is very bad, right? And see, in the earlier classes we have seen that surface finish of a casting product is very bad, right? Casting product is very poor. So now what thing you can do? So for that you have to trim the things, right? So when you will trim these things from all the sides, then you will get a good surface finished body, right? A good surface finished body. But see, to do this you have to forget about this extra part. See, you have to forget about this extra part. This extra part is being removed. This extra part is being removed while machining, right? This extra part is being removed while machining. So there is a loss in the material. So what is the steps that we should do? And here also we give some allowance to the pattern, and that is called as machining or the finish allowance. So see here, casting objects are not having smooth surface finish, right? Smooth surface finish. So to get smooth surface finish, machining So machining is required. Machining is required. So this is the thing that we have seen, right? Because casting objects are not having a smooth surface finish, and hence to get a smooth surface finish, machining is required. And see, due to machining, due to machining, due to machining, size of casting will be reduced. Okay, will be reduced or decreased. Therefore, therefore, size of pattern can be increased. Okay, size of pattern can be increased by providing allowance. By providing allowance. And see, sir, this allowance is actually machining allowance. This allowance is machining allowance. Clear or not? Machining allowance, clear or not, sir? So this is the machining allowance. This is the funda of machining allowance, that why we give the machining allowance and what is the need of the machining allowance. Okay, sir, machining allowance clear हुआ कि नहीं? सर machining allowance clear हुआ कि नहीं? machining allowance आई होप क्लियर हो चुका होगा, और अगर नहीं क्लियर हुआ तो भी मुझे बता दें, मैं फिर से एक्सप्लेन कर दूंगा. ठीक है? Okay. Now see, next allowance is draft or tapper allowance. See, draft or tapper allowance. What is this draft and tapper allowance? Please see here. Please see here. Suppose this is the casting thing, right? Now यहाँ पर क्या है सर, आपने ये कास्टिंग का आपका मोल्डिंग सैंड है सर, सैंड है यहाँ पर, पूरे जगह पे सैंड भरा हुआ है. ठीक है, आप इसके बीच में क्या कर रहे हैं सर, पैटर्न को डाल रहे हैं. ठीक है, यू आर गिविंग द पैटर्न. नाउ सी, पैटर्न इज लाइक दिस. Okay, so this is your pattern. Okay, so this is your pattern and this is your pattern, and and see, this is your sand, molding sand is the right. So entire thing is with the sand, molding sand is there, and in between them there is the pattern. Okay, so this is all, everything is molding sand. So this is molding sand. Okay, and this is your pattern. This is your pattern. Now see, what is the problem? What is the problem we face while lifting that pattern? सर पैटर्न तो हमने डाल दिया, रैमिंग भी अच्छे से कर दिया. अब जब रैमिंग कर दिया तो मोल्ड कैविटी तो तैयार हो गया ना, मोल्ड कैविटी तैयार तो हो गया. बस मुझे जरूरत क्या है सर? द नीड इज दैट आई हैव टू लिफ्ट दैट पैटर्न from that molding sand. Clear? So I have to lift that pattern. Now see, when I will be lifting that, see, when I will be lifting that pattern, what would happen? Suppose this is the thing, and you are lifting the pattern, right? So suppose you are lifting it. So you have lifted it like this. Okay, so you have tried to lifted it. But see, there was this something like this cavity was there, again this cavity was there, and this throughout this thing is holding sand. Okay, now see the problem. This was your pattern. So this was your pattern. But when you have tried to lift this, when you have tried to lift this, the problem is that throughout the throughout the molding, there would be a crack generation, right? There would be a क्रैक हो जाएगा सर, ठीक है, क्योंकि सर इसका शेप ही ऐसा है, द शेप ऑफ द पैटर्न इज प्योरली स्क्वायर, राइट? सो इसके कारण क्या होता है ना सर, वहां पर एजेस काफी शार्प हैं, जिसके कारण जब मैं लिफ्ट करता हूं तो क्रैक जनरेट हो जाता है, ठीक है? सो हियर इज द क्रैक फॉर्मेशन, and due to this crack formation, mold mold get damaged, mold get damaged. ओके, सो मोल्ड गेट डैमेज। तो अब मोल्ड जब डैमेज हो जाएगा तब तो मेरा तो कोई मतलब ही नहीं हुआ, इतना सारा मैं काम किया, एंड एट द एंड ऑफ द टाइम माय मोल्ड गेट डैमेज। सो व्हाट इज द यूज फॉर दैट? सो व्हाट वी आर डूइंग टू काउंटर दीज थिंग्स, व्हाट वी आर डूइंग, वी use a different type of pattern. We use a different, same pattern is there, but we give some allowance to this pattern. And what is this? You will be able to understand. Just see here. See, instead of that, what we are doing, we have given some allowance to this pattern, right? We have given some allowance to this pattern, and see what is there. See, this kind of thing would be formed. So this kind of thing would be formed entirely. This is the sand, molding sand is there, molding sand is there, clear? So everything everywhere is molding sand is there, and now you have changed the pattern, and this is your pattern, and this is your pattern, clear? Now you can clearly see, now you can clearly see there is a ease. जब अब हम क्या करेंगे, अब मैं अगर जब पैटर्न निकालूंगा ना, ये काफी इजीली हम इसको निकाल सकते हैं. इट इज वेरी इजी फॉर मी टू जस्ट pick that pattern, right? Because due to this you have given some, see, some different, like this much part is being added in this pattern, this much part is being added in this term, and see in this pattern this is the taper thing, right? Taperly some extra material has been added to this pattern, and hence it is known as taper allowance, trapper allowance, clear? So see, when you will lift this, then at this condition no crack formation would be there, no crack formation would be there. So no crack formation would be there, and you can see, sir, you can see here that this much amount of pattern is there, and this is the pattern, and see this much amount, this much amount is the extra material, right? So this is the extra material, this is the extra material, this all thing is extra material, okay? This all thing is the extra material. So positive allowance is there, right? So we are giving the positive allowance, clear? तो ड्राफ्ट अलाउंस की कहानी समझ में आई, ड्राफ्ट अलाउंस की कहानी समझ में आई कि पॉजिटिव अलाउंस क्यों हो रहा है, क्योंकि मैं एक्स्ट्रा चीज दे रहा हूं, ठीक है? ये हो गया पूरा ड्राफ्ट अलाउंस का कहानी. ड्राफ्ट अलाउंस इज क्लियर और नॉट? सर, this is the allowance that we are giving in this pattern, and this is due to this no crack formation is there, and this extra material is, and hence this extra material is given as a positive allowance. ठीक है सर? धीरज जी, साईं धीरज जी, फर्स्ट लेक्चर मैंने कल लिया है। फर्स्ट लेक्चर यू कैन वॉच इन दिस सेम चैनल, देयर इज अ रिकॉर्डेड लेक्चर, हाउ मेटल टू मेटल कास्टिंग। गोस्वामी जी, आई कैन नॉट अंडरस्टैंड योर क्वेश्चन। चलिए, बढ़िया, आपको समझ में आ गया, दैट्स गुड, दैट्स गुड। So what is the thing that we have understood here? So draft or taper alliance is what? To reduce the chances of damage of the mold, right? Damage of the mold. So see, we have seen that what is the problem that we are facing when we are removing this kind of pattern, then there is a chances of the crack formation and molds get damaged, and hence what we are doing, we are giving the taper allowance to see, to reduce the chances of the damage of the mold cavity at the time of pattern removal. The vertical faces of the pattern are always tapered from the parting line. This provision is called as draft allowance. This is called as draft allowance. Now see, inner surface of the pattern requires higher draft than the outer surfaces. Draft is always provided as an extra metal, and see, I have told you draft is always provided as an extra material, extra metal, and hence it is as a positive allowance, right? We have to add it, so it is a case of a positive allowance. Clear? सबको समझ तो आ ही रहा है? Good, 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 बहुत अच्छा। चलिए, next thing we are going to see, shake allowance. See, shake allowance, what is shake allowance? A shake allowance is also known as by one another name, that is wrapping allowance. What is shake allowance and wrapping allowance? Do you have any idea what is shake allowance and wrapping allowance? चलिए, कोई बात नहीं है, मैं आपको बताता हूँ। See, when you are removing the pattern, right? So when you are removing the pattern, so before removing the pattern, whole apparatus, right? Whole apparatus is, or whole arrangement is little bit shaked. When you have watched these things in your workshop, you have seen that the arrangement is little bit shaked, and after shaking that arrangement, this pattern is removed, right? This pattern is removed, and this is known as shaking or shake alliance. See here, see, before withdrawal, so before withdrawal of pattern, the arrangement the arrangement is shaked. The arrangement is shaked to enlarge the mold cavity, right? Because see, बहुत tight होता है, ठीक है? Pattern and mold, everything is in very tight, no clearance is there, so to provide little bit clearance between them, so that the material, so that pattern removal becomes easy, hence we are shaking this apparatus, and see, before withdrawal of the pattern, the arrangement is shaked to enlarge the mold cavity, right? To enlarge the mold cavity, and slightly, right? It is slightly enlarged, which which facilitates its removal, right? Its removal is being facilitated, right? And since it is since it is enlarging the final casting made, because see, when you are giving some shaking allowance, when you are giving the shaking to this arrangement, the cavity gets enlarged, and hence casting the size of the casting will also be enlarged. Clear or not? कास्टिंग का साइज भी क्या होगा सर, बढ़ जाएगा, एंड हेंस इट इज enlarging द फाइनल कास्टिंग मेड, so negative negative allowance is provided. समझ में आया या नहीं आया? Hence negative allowance is provided. Clear or not? Hence negative allowance is provided to compensate. Clear? To compensate negative allowance को हम provide करते हैं. ये शेक allowance समझ में आया कि नहीं आया कि कुछ प्रॉब्लम है शेक allowance को? ठीक है. अच्छा, एक बात जो मैं बता दूं इसमें कि क्या होता है, this allowance is highly dependent on foundry personnel and practices involved. तो सर ये काफी ज्यादा फाउंड्री पर्सनल पे डिपेंड करता है, इसका कोई पैरामीटर नहीं होता कि शेक अलाउंस में इतना दे दूं उतना दे दूं. दीज एवरीथिंग इज बेस्ड ऑन द एक्सपर्टीज होता है सर. तो मोस्ट इम्पॉर्टेंट थिंग इज this, that negative allowance is provided. Negative allowance is provided in case of a shake allowance. Why negative allowance is provided? Because it is eventually enlarging the final casting. When the arrangement is shaked, the cavity gets enlarged. When the arrangement is shaked, cavity gets enlarged, hence the dimension of the final casting going to enlarge, and hence casting size get enlarged. So we have to compensate that enlarge with this negative allowance. Clear? See us, see. देखिए आशीष जी, इस फिगर में देखिए, ये जो फिगर है, पहले पैटर्न मेरा ये था. Earlier pattern was my this, right? My pattern was like this. But due to after giving this taper allowance, what we are giving, we are adding the material to this side. Right? So when we are adding the material, so extra material is being added. So you are adding the extra material to the pattern, and hence the allowance that is being added is, this is called as positive added positive. Clear? Now see, sake allowance is what? Since final casting is being enlarged, so my final casting, suppose what I'm trying to say, see here, suppose if I am saking, if my requirement is this, right? If my requirement of the casting size is this is the required, but after the shaking allowance, see, my cavity gets enlarged. So suppose this is the cavity that gets enlarged. Now this is the enlarged cavity, enlarged mold cavity. This is the enlarged mold cavity, and see, the size is increased. So when I will do the casting at this mold cavity, my final casting product will increase. But I need this. Required thing. So I have to convert some of the parameters should be there, so that my final dimension should be like this. So to convert this thing into this, we have to allow the negative allowance is being provided to compensate this. Clear आशीष जी? ओके, गुड. सबको क्लियर हो रहा है? ठीक है. नाउ सी, next allowance is very most important, that is distortion allowance. This allowance is very much important. Distortion allowance or camber allowance. Now see what happens sometimes when we are doing the casting, so casting gets distorted. क्या होता है सर, जब मैं कास्टिंग के लिए मेटल को पोर कर देता हूँ मोल्ड कैविटी में, और उसको जब सॉलिडिफाई करने के लिए देता हूँ, तो फाइनल कास्टिंग जो प्रोडक्ट होता है, कुछ डिस्टॉर्ट हो जाता है, कुछ उठ जाता है, डिस्टॉर्ट हो जाता है पूरे तरीके से. due to its typical shapes. Like shapes are very typical, very intricate shapes are there. So what happens, that sometimes sometimes casting get distorted. So during solidification, clear? So during the solidification, casting get distorted, and this is because because of its its typical shape. Its typical shape. See, reasons may be different why they are be distorted. See, first I will show you some example, then I will tell you, because otherwise you will not get a feel that what sir has been telling to us. See what happens. Suppose if you have this kind of thing, कुछ इस तरह का चीज सर आपको अगर कास्टिंग करना है, तो क्या होता है, प्रॉब्लम क्या होता है कि दिस इज द this is the required shape of casting. This is the required shape of casting. Now see, what is the problem, that this is the required shape of casting, but when you will do the casting, you will get the material, you will get the final casting product like this. You will get the final casting product like this. Now see, this kind of final product is known as distorted casting. Distorted casting. Clear? Now see, to counter this, to counter this, to counter this, this kind of problem, to counter this kind of problem, what is being done? This kind of pattern is made. So from earlier, this kind of pattern is made. पहले से ही कुछ इस तरह का पैटर्न बना लिया जाता है, तो क्या होगा, पहले से अगर मैं इस तरह का पैटर्न बना दूं, तो फिर वो डिस्टॉर्ट होकर के फिर कुछ इस तरह का डायमेंशन में आ जाएगा. एंड सी, दिस काइंड ऑफ पैटर्न हैज अ पर्टिकुलर नेम, दैट इज नोन एज कैम्बर्ड पैटर्न. कैम्बर्ड पैटर्न. समझ में आ रहा है? समझ में आ रहा है? जैसे आपका रोलर होता है ना, रोलिंग प्रोसेस में we have seen that is a roller, right? So roller is also it is also given the cambered pattern, है ना. कैम्बर अलाउंस उसमें भी हम देते हैं, ठीक है, ताकि क्या होता है, जब कास्टिंग करूं तो मेरा रिक्वायर्ड शेप ऑफ द कास्टिंग आ जाए. अब आप बोलोगे कि सर व्हाट इज द रीजन, व्हाट इज द what is the reason, why ऐसा होता है, क्यों ऐसा होता है, why distortion is happening? Because सर सिंपल चीज है कि मैं तो इस तरह का पैटर्न बनाया, ये इस तरह का पैटर्न बना दिया, उसको डाल दिया हूँ मोल्ड कैविटी में, अच्छी तरह से रैमिंग कर दिया, निकाल दिया, सिंपल सी बात है. फिर मेटल को पोर करूंगा तो प्रॉपरली सेम चीज मिलना चाहिए, लेकिन ऐसा चीज क्यों मिल जा रहा है, व्हाई आई एम गेटिंग दिस थिंग? सो रीजन इज वेरी सिंपल, ड्यू टू द internal stresses. इंटरनल स्ट्रेसेस, मेटलोस्टैटिक फोर्सेस होते हैं सर ड्यूरिंग कास्टिंग, तो उसके कारण क्या होता है, इंटरनल स्ट्रेसेस का डिसबैलेंस होता है, हेंस ये ऐसा होता है. एंड मोस्ट इंपॉर्टेंट थिंग इज देयर इज नॉन यूनिफॉर्म कूलिंग. So non-uniform cooling of casting is there, and hence कहीं पे ज्यादा अच्छे से कूल हो गया, कहीं कम कूल हुआ, तो जहां पे ज्यादा कूल हो गया वो डिस्टॉर्ट कर गया, तो इस तरह का कुछ प्रॉब्लम होता है. एंड ड्यू टू दीज प्रॉब्लम्स वी we have a solution, we do the cambered pattern, right? And due to this we give an allowance, that is distortion or the cambered allowance. Okay, I'm telling once again. See, distortion. Okay, once again, I'm telling Ganesh ji. See, what is the distortion or the camber alliance? Sometimes in a casting, what we see that this is the required. See, this is a required shape of a casting. But what we do when we do the casting, we find this kind of thing. We encountered this distorted casting. But see, we do not want it distorted casting. So to get rid of this distorted casting, we are making the pattern as a cambered pattern, and this cambered patterns this in this like of fashion, and due to this we can get the this required shape of the casting. So why this is happening, we have seen due to the internal stresses and due to non-uniform cooling of the casting. So casting is not casting did not cools very uniformly. That's what we have seen in yesterday's class. This is the reasons non-uniform cooling of the casting is there. Clear? So this is what is the a distortion or the camber allowance. Clear? Now see, you can see that camber allowance, this is also known as inverse inverse reflection. Inverse reflection. So this distortion allowance is clear to you, or should I give any other example of distortion allowance to get a feel? See, rolling, we use a roller, and in this roller also we are giving the allowance, that is distortion allowance. Clear? Till now everything is clear to you? Till now everything is clear to you? I'm not getting it. Okay, so you are not getting it. Okay, okay. For you, see, suppose Asis and everybody, please see here. Suppose you have this kind of, suppose you have a I section. Clear? Suppose you have a I section. So this I section would be like this. So this is what is the I section, and see, this is the this is the required shape of casting. This is what you want to make. This is what you want to make. Right, this is what you want to make. Suppose you, this is a I section, and this I section you want to cast. But what is the problem that is happening? What is the problem that is happening due to this distortion? What is this distortion, sir? Due to these things, due to the internal stresses and due to the non-uniform cooling of casting, what is happening, sir? You are getting a different thing like this. You are getting a distorted I section. So you are getting the distorted I section. Clear? Something like this you are getting. Something like this you are getting. Clear or not? Something like this you are getting. So something like this you are getting. So see, this is the distorted thing. This is the distorted casting. This is the distorted casting, and this is not required. This is not required. Understood or not? So this is the required shape of the casting. This is what I want, but I got this. I got this distorted casting. So this is, there is no need of this. So why? What should I do so that uh, I will get a proper required casting? So to counter this, what is there? To counter this, what is there? We are giving the camber to this. We are giving the camber, that is the camber pattern is there. So what is the cambered pattern? See here the cambered pattern. The cambered pattern would be like this. So there is these kind of camber we give to the material, and see this kind of allowance when we give to the pattern, this is known as, this is known as cambered, this is known as cambered pattern. अब समझ में आया या नहीं? Cambered pattern. So see, this is the another example. I have taken the example of a I section, example of a I section. Okay, and this was the same simpler example was there. So this is the another example. Now everything is clear to you. Now I think distortion allowance is clear to you. Clear or not? Now distortion allowance is clear or not? Yes, sir, I got it. Okay, good, good. Now please see, we have talked about the allowances कि सर allowances जो होते हैं वो क्या क्या होते हैं, कैसा होता है allowances, and these things we have seen. These things we have seen. Now, what is the pattern material? What should be the pattern material? What should be the pattern materials? See, wood patterns are relatively easy to make. Wood is not very dimensionally stable. Commonly used teak, white pine, and mahogany wood. See, sir, wood patterns are always also used, right? Wood patterns are also used, but the problem is that, but the problem in the wood pattern is that these wood pattern are not very dimensionally, these wood pattern are not very dimensionally stable. Clear? So wood pattern has a problem that it is not very dimensionally stable, and see the materials that we can use, that is the common, is these kind of woods. Now see, next thing is we can use the metal patterns. We can use the metal patterns, right? But the problem is that metal pattern is more expensive, right? We can, wood is easily available, so it is easy to make as well as relatively cheaper. But see, when we are talking about the metal patterns, they are very much expensive. But see, even if it is expensive, the most important point is that they are more dimensionally stable, right? More dimensionally stable. What is the meaning of dimensionally stable? The meaning of dimensionally stable is, sir, that whatever the dimensions I am giving to you, suppose the 2 mm or 2 cross 1 mm is the dimension of the body, so that 2 cross m 2 cross 1 is going to be stable, fixed throughout the casting processes, everything is there. But in wood is the, what is the problem, sir? 2 cross 1 may be equal to 1.98 or 1.99 into 0.99. So these kind of things may happen because wood is very fragile, right? We know that wood is very fragile, and comparatively with the comparison with the metal patterns are very much stronger, and they have the uh, molecules are very strongly bonded. So these metal patterns are more durable also, right? And the commonly metal patterns are cast iron, brass, aluminum, and the white metal. Now, instead of this, next is hard plastic. So we can go for the wood pattern, we can go for a wood pattern, we can go for a metal pattern. Now, what else we can go? We can go for a hard plastic. We can go for a hard plastic, and hard plastic is made of the urethanes, and these things are there. Next most important is there this, the full mold process. For a full mold process, what we do, sir, we use expanded polystyrene, EPS. We are going to see this where EPS is used, and there is one most important special casting is there with the when in which expanded polystyrene are used, right? So we are going to discuss those things. Next most important investment casting is there. So this is also a special casting in which we use wax pattern. We use wax pattern. Okay. So what we have seen that wood can also be a pattern, metal can also be a pattern, hard plastic can also be a pattern, and wax can also be a pattern. Clear? So patterns का मटेरियल जो है सर, ये सब कुछ होगा. So these are the materials of the patterns. Clear? Now see, the pattern materials should be, what is the benefit of these things. So pattern materials should be easily worked and shaped and joint, very light in weight, strong, hard and durable, resistant to wear abrasions, right? Any abrasions and any wear and tear, so this material should resist. So these are the properties that it should have. And apart from that, it should have resistant to the corrosion and the chemical reactions. These things are very much important. And dimensionally stable, it should be dimensionally stable, and there should not be any effect in their dimensions with the temperatures and the humidity, and they should be like cheaper, they should be available at the low cost. So these are the materials, right? Now if you will you can solve this question. Disposable patterns are made of, see, in this case polystyrene, these things are right, so these are made of the disposable pattern. Disposable patterns are here. We are going to discuss these things in the next subsequent classes. So disposable patterns are made of the polystyrene, so we make the disposable patterns with the polystyrenes. Now see, now what we are going to understand the types of pattern. We have seen now, till now we have seen pattern. What is the pattern? And pattern, we have understood that it is a replica of the material what we want to cast, right? So see, so there are a lot of types of pattern. So there are a lot of types of pattern. There are a lot of types of pattern. So what are they? What are the those things? First type is single piece pattern, right? So single piece pattern is there. So we are going to see this single piece pattern. See here, there are a lot of pattern types, so we are going to see one by one everything. Now what is single piece pattern? What is single piece pattern? Now see, single piece pattern, the name itself says that the pattern is in single piece. The pattern is in single piece. Now what is the meaning of single piece? Suppose I want to make a casting of like this, right? Of like this. So this is a single piece pattern. So single piece pattern is used only where job is very simple, right? Very simple, like this. You can see, if we want to make a casting of this kind of body, this is very easy task, very easy task. So to make the casting of this, we use the single piece pattern, and these kind of patterns are known as single piece pattern. Clear? Now see, next pattern that is known as split or two piece pattern. Split or two piece pattern. Now see, what is the split or the two piece pattern? Now see, this is the figure. Let me draw the figure. See, this is the single or two-piece pattern. What is the meaning? I am going to explain you. Just a minute. Now see here. See here, what is there? See here, what is there? So this is the two-piece pattern. So one pattern is there, and I cut these two patterns in the two pieces, right? And I'm connecting this two pieces pattern with a pin, with a pin. And see, you can see a projection is there in this part. So a projection would be there in this part, right? So see, these pins, right? These pins are known as dowel pins. Dowel pins. So with helps of dowel pins, what we are doing, these two pieces patterns are covered, right? So now see, the final thing is what? Final thing is what? Final thing is like this. I think that my cam is blocking that area. Right, so this is the final pattern, right? So where it is used for making it is used for making intricate casting. It is used for making intricate casting, है ना sir? Where two-piece pattern are used, wherever you have very intricate shapes and structures are there, so in that cases use the two-piece pattern, right? See, what is the speciality of this pattern is that it is split along the parting surface. And what is the parting surface? I have told cope and drag, right? Remember the earlier class, cope and drag, and the line parting this cope and drag part, that is known as parting surface, right? So see, one half, right? Let me write it here. So this is the one and this is the another part, right? And combining these two things, right? See, this is this and this is this, right? So one half of the pattern is molded in drag, and other half in cope, right? In earlier class we have seen what is drag and what is cope. So see, one half is molded in the drag and one half molded in the cope. So these are the two things, right? These are the two things, and these kind of patterns are known as two-piece pattern. Two-piece pattern, clear or not? How much cover are joined today, sir? Yesterday I have given the classes. Yesterday was the part 1 and this is the part 2. In this part 2 we have been discussing these things. We have discussed machining and finish alliance. We have discussed draft or taper alliance. We have discussed shake alliance. We have discussed the distortion and the camber alliance, as well as we have seen the two examples related to it to get a good insight with that, as well as we have talked about what should be the pattern materials, as well as uh, types of patterns we are discussing right now, and that is a single piece pattern and the split or two piece pattern. Clear or not? Everybody clear or not? Now see, next pattern is cope and drag pattern. Next pattern is cope and drag pattern. Now see, these are similar to split patterns. In addition to splitting the pattern, Scope and drag halves of the pattern along with the gating and riser systems are attached separately to the metal or wooden plates along with the alignment pins. They are known as scope and drag pattern. See, you will not understand this thing. You will not understand this thing. So I will come to the scope and drag later on. Let me give some time and then you will understand this scope and drag pattern. See, match plate pattern. What is the match plate pattern? What is the match plate pattern? See here. What is the match plate pattern? Suppose this is the plate. Suppose this is the plate. Now in this plate, if this is, so suppose something like this, right? So this is the first part. So this is the first part, one half of the pattern, one half of the pattern, and the other half, of the pattern is like this. And the other half of the pattern, would be like this. Okay, so this is the first half of the pattern and this is the second half of the pattern, right? And see, this plate is actually known as match plate. Match plate. Let me give you one more example, then you will understand. Suppose there is a plate. So suppose I have put a plate, and on this plate I have put the pattern. So suppose this is my pattern, again this is my pattern, again this is my pattern. Now these patterns are connected with the runners. What is the runner? Suppose these patterns are connected with the runners. Runner is what? Runner ensures the flow of the molten metal. Suppose these patterns are connected with the runners. This is the runners. Suppose the pattern is connected with the runner, and how many patterns are there? A lot of pattern. A lot of pattern. This is the runner. This is the runner. This is the runner. So see, what is the learning that we are getting from here? This is my pattern. This is my pattern. This is my pattern. Right? Everything is pattern. Now this is my runner. Runner ensures the flow of a molten metal. And this is the plate on which these patterns are placed, right? These patterns are placed. This is known as match plate. So there is a plate, and on this plate, I am putting suppose this is my plate. This is my match plate. And on this match plate, I am putting the one pattern above this and another pattern above this, like this, right? One pattern here, one pattern here. See, one pattern here, one pattern here. And based upon that, see, this is the first half of the pattern, this is the second half of the pattern, first half of the pattern, second half of the pattern, first half of the pattern, second half of the pattern. And these things are put on a match plate. So this kind of pattern are known as match plate pattern. Match plate pattern, where it is having a runner, where it is where patterns are arranged in this kind of things. So see, it consists of a match plate match plate on either side of which each half of a number of split pattern is fastened. See, I have already told you how they are fastened. Suppose these are fastened by the pins. Okay, so pin is there, pin is there, pin is there. With the pins, with the help of the pins, these patterns are fastened on the match plate. So I think this match plate pattern is clear to you. Match plate pattern is clear to you. What is match plate pattern? Clear or not? Match plate pattern. Tell me, match plate pattern is clear or not? Please tell me, match plate pattern is clear or not? If it is not clear, then I will explain it once more. Tell me, difference between split and match pattern is, see, Mukta, difference between split and match pattern is there. They see, we are not giving any match plate or any plating, or any plating is not there in between the two patterns, right? This is the two split pattern is there, but I'm not giving any match plate to match those patterns. But here what I'm doing, I'm just giving the a plate, a match plate to match those two splitted patterns, and this is the difference. Match plate pattern, this is the only difference there. This is the only difference is here. Clear? Yes, Assis, here we are adding the extra plate. Now see here. Now see, no, see, Mukta, see, these are the types. These are the types. In general, these lot of pattern types are not even used. Then why we are studying? Because these everything is in your syllabus, and from any of the topics, questions may be asked. So there is a need to understand every patterns, whatever the patterns are there in our syllabus. Okay. Now see what is there. Suppose this is my casting, and this is my, suppose this is my pattern. This is first pattern, this is second pattern, again this is also my pattern, this is my pattern, this is my pattern, this is my pattern. See, these all things are pattern, so these all are patterns. Okay, now see, this is gate, this is gate, and this is runner, this is runner. See what is the things that we can see here. See, if I will pour the molten metal, suppose if this kind of arrangement is there, if I will pour the molten metal, so this is the runner, from runner molten metal will be poured, and see, from gate allows to this molten metal to flow inside these things, right? See, so when the gate will allow, then the molten metal will get filled in every cavities. See, molten metal will get filling every cavities like this, right? So this like this. Clear? Like this. So every cavities are filled. So just at a single time, just at a single time, you are making a lot of castings, right? Just at a single time, you are making a lot of casting, a lot of casting you can make, and hence this kind of things are known as gated pattern, right? So gated pattern is there. See where, what is the need of that? Sir, कभी कभी क्या होता है, हमें हमें बहुत सारा प्रोडक्ट, कास्टिंग प्रोडक्ट बहुत कम टाइम में बनाना पड़ता है। मास प्रोडक्शन के लिए जब हमको यूज करना है, वेन एवर आई हैव अ डिमांड ऑफ मास प्रोडक्शन, आई वांट टू मेक अ casting in very humongous masses, then I make this kind of pattern, and just for example like this, like suppose 50 at this side, suppose 50 at this side and 50 at this side, like this. So total 100, right? So total 100 casting you are making. Just you are pouring the molten metal, and at like 1 or 2 hours you are getting the 100 casting, right? So see, this is the speed, and hence these things are employed employed for mass productions, right? And also these are employed for small castings. These are employed for small castings also. Sahid Ali, how can you prepare in one day? How can you prepare in one day, Sahid? One day is not enough for the manufacturing until unless you have some guides or anything. तो चलिए आप एग्जाम तो दे दीजिए, एग्जाम के बाद मेरे वीडियोस को थोड़ा फॉलो करें, ताकि फर्दर जो भी आप एग्जाम देना उसमें आपका बेनिफिट हो, ठीक है? So I hope this gated pattern is clear to you, right? So see here, produce produce the runner and gate for each cavity in mass production manually will take more time, right? If I will make a separate cavity for like 50 and 50 is there, suppose if I am taking a one cavity will take like 1 hour, so like 100 cavity I have to make, so I will require 100 hours. So this is like waste of the time, right? So to produce the runner and gate for each and every cavity, mass production manually will take more time, and hence to overcome this kind of problems, to overcome these problems, to overcome these problems, number of patterns along with number of patterns along with gating elements gating elements will produce a single pattern called as gated pattern. Clear? नोट्स क्या बोल रहे हैं साहिद जी? नोट्स, व्हाट काइंड ऑफ नोट्स? What kind of notes you are talking about, Sahid? Tell me. Sir, gated pattern is clear to you or not? So match plate pattern is there, gated pattern is there. Gated pattern is clear or not? Tell me. Tell me. Now see this. Tell me and I will tell you. You can see there is a runner, right? Runner is there, gate is there. So these things are there. Now just go back to the cope and drag pattern what we have seen. See, See, just now what we have seen, there is a split piece pattern, and this pattern is splitted like in two halves, first half and the second half. Two halves are there, second half and first half. And see, these are similar to split patterns. In addition to splitting the pattern, cope and drag halves of the pattern along with this gating and riser system. See, what is the meaning of gating and the riser system? So see, these kind of gating and the riser systems are there, right? So are attached separately to the metal or a wooden plate along with the alignment pins. These are known as scope and drag pattern. So these are similar to the gated pattern. Gated pattern is not clear to Subham Singh. Subham ji, kindly see it here. What is there? What is the problem that if suppose I have to make this is if suppose I have to make this, suppose I have to make only this, right? Now to make this for a one single casting, I have to make runner and getting system, right? Now to make a gating and a runner system for this alone for one casting is the waste of money as well as waste of time. Clear? For mass production, what we are doing, we have made a technique we have made a technique in which 50 castings are on first half, 50 castings are on second half, and just now we are pouring the molten metal here, and once we are giving the molten metal at a random again 50 and 50, like 100 amount of castings get produced at a fraction of hours. Clear? So this is what is the gated pattern, है ना? समझ में आ रहा है? So there is a ways to make a runner and gate for a single thing. So why not we can make a runner and gate for a system in which like more than 100 or 200 or 500 of castings can be done at a one go. Clear? So this is what is a gated pattern. Now see the sweep pattern. Now see the most amazing and interesting thing is there. See, sweep pattern is there. Now see, for example, this is this is this is the mold. This is your mold, and suppose this is your pattern. Okay, so this is your 2D pattern. This is your 2D pattern. Okay, so suppose this is my mold. This is my mold cavity. This is my mold. Cavity is not there. This is my mold. Now see, if I want to make a conical, if I want to make a conical mold cavity, if I want to make a conical mold cavity, what I will do, I will take a 2D pattern, right? I will take a 2D pattern and fix this pattern from this end, right? Fix this pattern from this end, and I will rotate it. I will rotate it. I will rotate this pattern and see if I will rotate this pattern, then I will be getting something like this. So this is my axis of rotation, and if I will rotate it, then I will be getting this kind of thing. Okay, so this is my mold. This is my mold cavity. Mold is there, and due to rotation of this 2D pattern, I am getting the 3D mold cavity, right? So this is the 3D mold cavity. 3D mold cavity. Clear? This is the 3D mold cavity what I am getting. So this is the sweep pattern. See, this is what is the sweep pattern. To produce complex shape of three-dimensional three-dimensional mold cavities, 2D plane pattern will be rotated on the surface of mold to produce 3D cavities. Okay, to produce 3D cavity. Clear or not? Clear or not? This is what I have written. To produce the complex 3D like this, ये अगर मुझे प्रोड्यूस करना है तो मैं क्या करूंगा, 2D पैटर्न लूंगा और उसको जस्ट रोटेट कर दूंगा, 360 डिग्री रोटेट कर दूंगा, एंड फॉर दैट आई एम गेटिंग द 3D cavity. For that I am getting the 3D cavity, right? So this is the first point, and the second point is most important. It is used for axis symmetric, is used for axis symmetric objects only. So what are the examples, what are the products that we can make from the sweep pattern? The sweep pattern, from the sweep pattern we can make cone, right? This thing we can see cone, or large size bells, right? Bells are like in found in temples. So temples in we see there are a lot of big sizes of bells are there. See, if you will observe the bells, the bells are like this. So something like this is there. So this, see, these things are axisymmetric, right? So firstly you just have to make this kind of pattern, and then you will rotate it, and when you will rotate it you will get the 3D cavity, right? So large size bells, you can make the large size bells, as well as like a cylinder, you can make the cylinder also, right? So these things that you can make with the sweep pattern, and this is the use of a sweep pattern. So even if you have not got any idea about the sweep pattern, let me give you one more example. See here, see this thing is clear to you? Is it visible to you? This figure is visible to you? Okay, this figure is visible to you. Now see what is the, see, this is the green sand what we have seen, this is the green sand, and see, there is this is the pattern, right? This is the sweep pattern. This is the sweep pattern, and what is being done, this sweep pattern is rotated, is this sweep pattern is rotated along this axis. Okay, so the sweep pattern is rotated along this axis, right? And when it will be rotated, see, this kind of mold cavity is being formed, okay? So this is the mold cavity, see how very much complicated pattern is there, shape is very intricate, and these things are there. But what we are doing, we just make the one half and we rotate it, and we are done with the mold cavity. Once we are getting the mold cavity, now what is our duty? To pour the molten metal here, and once I will pour the molten metal, let it be solidify, and after the solidification I will be having a very nice and clean casting product. Okay, so this was all about the sweep pattern. Sir, sweep pattern is clear to you? Sir, the concept of sweep pattern is clear to you. Now, see, now see, there is one more thing. There is one more type of pattern that is known as loose piece pattern. Loose piece pattern. Now see, now see in this figure. See in this figure. This is the loose, this is the pattern, right? This is the pattern. First, let me write it here so that you will be able to understand. This is the pattern. This is the pattern. And here you can see a small, these things is there. Okay. See, this is the pattern, right? So what you did, you just place the pattern, and once you place the pattern, and above this pattern you just filled this you just filled with this molding sand is filled there. At the entire reason molding sand will filled, and then you just do the ramming things, and after the ramming process end, what is the next thing? Next thing is, sir, you want to remove this pattern. You want to remove this pattern. Now see, to facilitate the ease to remove this pattern, what we are doing, we are giving some another small part, some is another small part of the wood or any metal is there or any pattern is there. So this small part is known as loose loose piece pattern. Loose piece pattern. And the loose piece pattern helps this pattern, main pattern, to facilitates its ease to get it out, right? So see, these type of patterns is also used when the counter of the part is such that withdrawing the pattern from the mold is not possible, right? See what we have seen here. Suppose, see, in the case of a draft or a taper alliance, what we have seen, that in this condition, see, when I was trying to lift the pattern, it was very difficult. It was very difficult. And see, hence what we have given some taper alliance to that. And see why it was difficult. When I was lifting it, everything was crack formation was there and mold was getting damaged. Mold was getting damaged. Now so too, so here kindly see it. I'm explaining once again. So what happens to facilitate the ease of this pattern? This is the main pattern. This is the pattern that you are interested to make the mold cavity of this pattern, right? Now see what I'm just supporting this pattern with some another loose pattern, that with some another pattern that is known as loose piece pattern. And what is the use of this loose piece pattern? To facilitate the ease to remove this pattern, right? To facilitate the ease to remove this pattern. क्या होता है सर, प्रॉब्लम क्या होता है कि कभी कभी जो पैटर्न होता है ना, वो इम्पॉसिबल हो जाता है निकालने के लिए. Sometimes there are the conditions that the operators or the foundry personnel feels that to lift this pattern is very much difficult or impossible. So in that case, what we do, we just provide some extra part, loose piece of the pattern, and this pattern helps facilitate to get it out, to get the main pattern out. And see, once you will take this main pattern out, but this loose pattern will left in the mold. So loose piece pattern will left in this mold. So these kind of things are there, and these cases are loose piece pattern. uh See examples, these things are very typical. See, whenever there is very intricate, just keep in mind आशीष, जब भी हमारा पैटर्न को लिफ्ट करना मुश्किल हो जाए, जब भी हमारा पैटर्न को लिफ्ट करना मुश्किल हो जाए. Now see, for example, I'm just drawing one more thing. Suppose suppose I have now suppose for example This is my mold cavity. Okay, so this everything is my mold cavity. Consider this to be as mold cavity. Sorry, this considered to be as a mold. Okay, green sand is there. There is a green sand. So here is a green sand, and this is your pattern. So let it be. This is your pattern. This is your pattern. Now, when you will try to lift this pattern, you will not be able to lift this pattern, right? Now, but if suppose what I will do, I will provide some loose piece pattern while molding, before molding, and if I will provide some loose piece pattern like this or like this, then see, when I have provided these loose piece pattern, this loose piece pattern, then when I will try to remove this, when I will try to lift this pattern, the pattern removal now becomes very much easy, right? So loose piece patterns actually facilitates this process. Now everything is clear. Now everything is clear or not? Loose piece pattern, this is clear or not? Loose piece pattern is clear or not? Tell me, loose piece pattern is clear or not? Tell me fast. I have already given the one more example, so I hope you will be able to understand this. The next is the follow board pattern. Follow board pattern. What is the follow board pattern? See here. See here. Suppose this is the mold, right? And suppose this is my pattern. See, this is the very different type of pattern is there. This is the pattern. Now suppose if I want to make a casting of this kind of pattern. Now what is the problem of this pattern? Can you tell me? What is the problem of this pattern? Is what is in terms of a strength? Can you tell me what would be the strength of this pattern? What would be the strength of this pattern? Till now what we have seen a lot of bigger size patterns, or a lot of things are there. Now the pattern is only this much. Only this is the pattern. Can you comment anything about its strength? What would be the strength of the pattern? Can you comment anything about it? Tell me. Lack of strength, yes. So I can say that this pattern is very fragile, and now once once you will once you will give the green sand, once you will give the green sand on this, right? Once you will give the green sand on this, and after putting the green sand, you will start ramming it, right? You will start ramming it. Then what will happen? Weak, Syam Babu told, has weak, Ases strength will be less. Yes. So what is happening when you will put this pattern, right? So this is my pattern, this is my pattern. Now when you will put this pattern on this green sand, above this green sand is there. Now what is the step? Your next step is to do the ramming process, right? To do the ramming process. Now there may be a chance that in the ramming process, this fragile pattern will break down, right? This fragile pattern will get break down, right? So so in order to help this to in order to support this pattern, now here here if a board is provided, here a board is provided, and this board is like this. So here a board is provided, and on the board, this is board made of a follow board. This is known as follow board, may be made of the wood, right? So so now if I will, if I will give the force to it, it will resist the force. It will resist the force. It will resist the force because a support has been given. A support has been given, right? A support has been given in this. So this is the use of a follow board. Okay, so this kind of pattern is known as follow board pattern. Okay, follow board pattern. Now see, if the patterns are structurally weak due to ramming force, there is a possibility of breaking of the pattern. Clear? This is what we have seen. Now, second thing is that to overcome this, patterns are supported by providing follow board, right? So these are the things in this. This is the first point, this is second point is there. So I hope this follow board pattern concept is clear to you, everybody. Namaste Nihar ji, namaste. Now I think this follow board pattern and every types of patterns is clear to you. Dear friends, the types of patterns की types सारी चीजें clear हो गई होगी, है ना? So till now, what are the types of patterns that we have seen? What are the types of patterns we have seen? First type is single piece pattern, right? Single piece pattern. Clear? Single piece pattern. Okay. Single piece pattern is there. This is the first thing, right? Second is what? Second is your split or two piece pattern, right? Third, what we have seen, cope and drag pattern. Fourth, what we have seen, match plate pattern. Fifth, what we have seen, gated pattern. Sixth, what we have seen, sweep pattern, right? And we have also seen loose piece pattern. Next, what we have seen, follow board pattern. So these are the types of pattern, 8 types of patterns we have seen, and these patterns are very much important for your understanding point of view. So I don't know how many of you are pass out of from BTech or whatever. So that's for sure. I know that in this much of details you are not knowing about the casting. Even if you have studied casting in your BTech and given the examination and passed the examination, but you really do not know about these kind of pattern, right? Because समझ में ही नहीं आता है, ये तो समझ में ही नहीं आता है. So I tried my level best to simplify the patterns types and get you visualize these patterns. So I think I am able to make you understand everything. Okay, and even if you have any problem till now, you are free to ask any questions. Now next topic that we are going to start is the properties of molding sand. Properties of the molding sand. Now see, what is the properties of a molding sand? So we have seen what is the molding sand. Molding sand is sand in which like green sand is there, facing sand is there, clays are there, right? Silica, everything, a lot of things we have seen yesterday. Some things are there, and clustering all the things we get the molding sand. We get the molding sand. So first property is flowability. Alok ji, I have skipped that thing, skeleton pattern, sir. Okay, so basically skeleton pattern is something like you can think about this. You can think about the gated types are there, but the problem, but see, a lot of patterns are there, like see there is a limitation in that. So in skeleton what we are doing, we are giving a lot of these patterns, and these patterns are very much intricate in there. Like see these, there is a limitation here. This, what is the limitation? Small casting only we can make, but in skeleton what we are doing, we are encompassing a lot of complicated or intricate patterns there, right? So this is what is the difference between gated and the skeleton. So I hope you can relate what is the skeleton pattern. Okay, now see, what is the flowability? What is the flowability? So so flowability, so it is the ability of the molding sand. It is the ability of molding sand to flow and get compacted all around the pattern and take up the required shape. How can you relate this flowability, sir? Sir, if I have a water, sir, if I have a water, and if I will pour this water into any container, the property of a water is that it will flow to any container and take its that shape, right? Take the shapes. So 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 it is the ability of molding sand to flow and get compacted all around the pattern and take up the required shape. Saurabh ji has told strength and porosity, heat resistant. Yes, see, Saurabh ji, there are a lot of strength, like hot strength is there, dry strength is there, green strength is there. We are going to talk with these things now. Okay, give me some time, I'm going to talk about this. So first property is flowability. So I think flowability is clear to you. Now second property I'm going to tell you. Second property is refractoriness. Refractoriness. Okay, now second property is refractoriness. So what is the refractoriness? See, again, it is the ability of the molding material to withstand the high temperature of the liquid metal to be poured, right? So whatever the liquid metal is has been poured, so these are at high temperature, right? These are at very high temperature. So molding material should withstand this high temperature, right? Withstand this high temperature. So yes, that, Alok, Alok ji, that's what I have told. What I have told. See, I have told you that, see here, see, Alok sir, see, this is the pattern. This is the pattern, right? These are the pattern. So what I have told you, in this case, small castings are used. The patterns are not very so much of complicated, as well as like small, less dimensional sizes, very less. These things are used in this gated pattern. So instead of that, what is the difference in the skeleton is that at these all things, we give the intricate shapes and size of the pattern. We give the intricate shapes and size of the pattern, as well as these size are, these gate size, these pattern size are very big. Okay, so like these things what we have seen, like like size of the bells, like these are very very big, very very big size are there. So you can make like this with these things. Okay, now, so this is the refractoriness. I think this is clear to you. जो भी जब हम गरम जब हम गरम pour करते हैं, when we pour the hot molten liquid metal, right, liquid molten metal into this molding material, then what happens, sir? This molding material or the molding sand should withstand this high temperature, right? And this is called as refractoriness. Now next thing is very 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 important. Next property that I am going to tell you is very very important. So please try to understand this property very much, because this is very important. This is very important. This is very much important. See, permeability. What is permeability? So it is the ability of the molding material to allow hot gases to pass through it. Okay, so it is the, just yesterday class we have seen what is the permeability, right? So it is the ability of a molding material to allow hot gases to pass through it, right? So it's very simple. It is written in a very simple language. Now see how we actually measure this, how we actually measure the permeability. Like suppose if I have a molding sand, how can I say that this molding sand has this much amount of permeability? Or suppose I have a three category of molding sand, so how can I know that which category of molding sand has better permeability, right? So how can we know, how can we know about that? So for that, so how can we know? So we can know this about permeability number. So there is a permeability number. So there is a permeability number. And what is this permeability number? What is this permeability number? This permeability number is the rate of flow of air passing through a standard specimen under a standard pressure is called as permeability number. Now see, what is the meaning of a standard specimen? Yes, Alok sir. Yes, permeability. This is the property of permeability. We have correctly told. Now see how we can measure the permeability. We can measure the permeability with the help of a permeability number, right? Permeability number. And what is this permeability number? This is the rate of flow of air. Okay, so whatever the flow of the air is there, so which is passing through the standard specimen, I'm drawing these things, okay, so that you can get a feel about it. So there is a standard specimen. So what is this standard specimen? Suppose I'm drawing it here. Now suppose this is my molding. This is my molding sand, right? This is my molding sand. Clear? So this is my molding sand. This is my molding sand, right? Now I will take a molding sand of height of height. What should be its height? Its height should be 5.08 centimeters. Suppose I have taken a molding sand of 5.08 centimeter. Clear? And the area is what? Area of this is 200 220.268 centimeter square. Clear? So what I have taken? I have taken a molding sand of height 5.08 centimeter and its area is 20.268 centimeter. Clear? Now what I am doing? Now what I am doing? I am trying to flow the air. Okay, I am trying to flow the air from here. Okay, air is being passed through this thing. So air is there. So this is the air. And see how much air I am passing through it. 2000 centimeter cube. So this much amount of volume of air I am passing through this specimen, right? So this through this specimen. Now this specimen, which is having a height of 5.08 centimeter, area 20.268 centimeter, this specimen is known as standard specimen. This is specimen is known as standard specimen. Clear? So now once again read this. The rate of flow of air. So this is the rate of flow of air. Rate of flow of air passing through a standard specimen, and this is my standard specimen. And how much volume of air I am passing through it? I am passing through it by 2000 centimeter cube. This much amount of volume of air we are passing through it under a standard pressure. This is called as permeability number. Now how we are getting the permeability number? Permeability number is actually defined by R equal to VH by PAT. Clear? R is equal to VH by PAT. So this is how the permeability number is defined, where V is volume of air, and we know that volume of air is having 2000 centimeter. एसपी सर, बात ये है कि for any examinations the syllabus of the casting is this is the syllabus of the casting. Okay, and if I do not know about the UPSSC sir, but that's as far as I my knowledge is concerned, the almost all the examination syllabus is this much. Okay, but you should check the syllabus once again, and if that is there, your preparation is already done. Okay, so prepare for that. Okay, prepare for that. Now see, so this is the volume of air that we have. Okay, now see, height, h is the height, right? H is the height of this specimen. We know that h is the height of specimen. H is the height of the specimen. Okay, now see, next is what? P. P is the pressure. P is the pressure of air. P is the pressure of air. Now most important point is that pressure of air is measured in gram per centimeter square. Okay, so pressure is measured in gram per centimeter square. Clear? Now see, next is what? Next is the area. Next is the area. So this area is actually cross sectional area of the sand specimen. Okay, and this we know that this is 20.268. Okay, so this is what is there. And next is the t is what? Time in minute. Okay, time in minute for complete air to pass through. Okay, so this is how the permeability number is defined. This is how the permeability number is defined. So always remember this formula, VH by PAT. But one more thing that is here, see here, this formula also reduces to R is equal to, now see, if you will put the value of V here, what is the value of V? V is 2000. If you will put the area here, right, area, if you will put area here, then you will get the relations, right? Then you will put the relations, and this relation, if you have a figure, if you have a calculator, then try to put the area value, volume here, and height, area, height, and volume in this equation, and tell me the equations that you are getting. Please, someone just put the value of area here, height here, and volume in this equation, in this R equal to VH by PAT, and tell me what is the new equation that you are getting for the R, for the permeability number. Tell me. Just put these values. Okay, let me write it here. So for that you will be getting 501.28 by PT. Okay, if you will calculate it, you will get this relation, 501.28 by. Clear? So this was all about the permeability number. Sir, height is this is the height, 5.08 centimeter. This is the area, 20.268, and this is the air, this is the volume of air. Clear? Volume of air. So we are getting R is equal to VH by PAT, and once I will put the standard specimens values, I will be getting R is equal to 501.28 by PT. Now most important thing in the questions, you will be asked to find the permeability number, and the units will be different. See here, once again I am telling you, see this. What is the unit of V? Volume. Unit is centimeter cube. What is the height? See, 5.08, right? So this is 5.08, right? So that is in also in centimeter. Now what is the pressure unit is in gram per centimeter cube. What is the area? See, area is 20.268 centimeter square, so this is also in centimeter square. Clear? Now T, what is the unit? T is in the minute. So always keep these unit system in your mind, because in questions, in the gate questions, they will just do blunders, right? They will in terms of minutes they will give the things in seconds, or the in terms of hour. For example, this is the pressure should be in gram per centimeter square, they will give in the Newton per meter square, right? What does defined permeability number? See, permeability number is what? See sir, सौरभ सर, सी क्या होता है कि मैं आपको जैसे पहले बताया था कि अगर आपके पास 3 या 4 मोल्डिंग मटेरियल्स आ जाएं, है ना, मोल्डिंग सैंड 3 या 4 मोल्डिंग सैंड आ जाएं, तो आप कैसे बता सकते हैं कि मोल्डिंग सैंड, अगर मेरे पास 4 क्वालिटी का मोल्डिंग सैंड है तो कौन से मोल्डिंग सैंड से परमिएबिलिटी ज्यादा होगा सर? परमिएबिलिटी ज्यादा होगा। व्हाट इज द परमिएबिलिटी सर? मोल्डिंग सैंड से हॉट गैसेस कितने इजीली फ्लो कर जाते हैं, दैट इज कॉल्ड एज परमिएबिलिटी, राइट? अब मेरे पास 4 सैंपल पड़ा हुआ है, मैं कैसे जान सकता हूं? तो क्या मेरे पास आइडिया होता है सर? माई फर्स्ट आइडिया इज टू मेक अ first idea is to make a standard specimen, right? I will make a standard specimen of the molding material. So suppose I have a 4 quality of molding sand, I will make the same height should be 5.08, area would be 20.268, and based upon this standard figures I will make the standard specimen of these 4 molding sand, right? Now what I will do, from these all 4 molding sand standard specimen, I will flow the 2000 centimeter cube volume of air from it, and then I will see how much time is being taken by these all 4 things, right? These all 4 quality of molding sand, and based upon that I will be able to easily identify that okay, this sand is taking less time, this sand is taking much more time. So based upon that I find a number, I find a number, right? A number is there, that number has been calculated, that sir, this number is a relation between V, H, P, A, T for that kind of things, and this number would quantify the permeability of the sand. So this is what is all about the permeability things. So I hope Saurabh, you have got the idea about it. Now just two or two three more properties are there, so let me finish it. How can define by molding? But sir, how can define? See, molding sand, देखिए, अब मैं आपको इसको कैसे समझाऊं? सौरभ जी जरा देखिए, सैंड का क्वालिटी, अगर मैं बिल्डिंग की मटेरियल्स की बात करूं, सैंड की क्वालिटी क्या होती है? मैंने देखा है कि सैंड का क्वालिटी काफी बड़ा भी होता है, साइज बहुत बड़ा भी होता है और बहुत फाइनर भी होता है, ठीक है? अभी आप एक चीज मुझे बताएं, अगर बहुत ज्यादा फाइनर होगा, इफ द sand would be very much finer, then inter gap between these two particles would be very less. How can be pH? These things are experimental, Saurav ji, these things are experimental, okay? These things are experimental, that these things, a standard specimen has been measured, and we these things that standard pressure like this, what is the pressure? So standard volume, standard height, these every standard has been fixed experimentally, a standard has been fixed, and after conducting this experiment these numbers has been given. Clear? This is not what you or I we are giving these things are experimental, okay? Now see, now see, next thing is, so what we have seen? We have seen first property is the flowability, second property is the refractoriness, and the third property is the permeability. Next property is, next property is green strength. Next property is green strength. Next property is the green strength. Now see, I have already told you, so whenever there is in the sand there is a presence of a moisture, so that sand is known as green sand, right? So what is the green strength? What is the green strength? The molding sand, the molding sand that contains moisture is termed as green sand. Okay. Now this, we know the molding sand that contains moisture is known as green sand. So this thing is clear to you. I have already told you in the earlier classes, right? So now if you talk about, so green strength is the ability, of the green sand, is the ability of a green sand to retain the shape of the constructed mold. What is the meaning, sir? कि मैंने पैटर्न डाल दिया, ठीक है, I have put the pattern in this mold, right, in this mold, and once I have put the pattern in this mold, and when I will remove this pattern, so there would be a cavity, so green strength is what? Green strength is the ability of green sand. That sand should have the ability to retain the shape of that mold. Okay, to retain the shape of that mold. So this is what is the property of the green strength. Okay. Now next most important property is the dry strength. Dry strength. Okay, so what is the dry strength? So it is also the ability of molding material to retain the exact shape of the mold materials in, but the condition is that it should be in the dry condition. Okay, it should be in the dry condition. Now see, what is the meaning of dry condition? It means that when the molten metal is poured in the mold. Okay, so see, in the dry conditions, no, it should have, it should also withstand the metallostatic pressures. Okay, so how the metallostatic pressures are formed? So metallostatic pressures are formed in the liquid material. Okay, of the liquid material. Okay, you just all think, Saurav sir, when moisture will be more, then what should be the strength of the sand? Tell me. You just think in what should be your answer? What should be your answer? Tell me. See, everything has its own limitations. Okay, जितना ज्यादा दे देंगे तो और भी खराब हो जाएगा. मॉइस्चर कंटेंट अगर बहुत ज्यादा होगा तो वो खराब हो जाएगा, ठीक है. बट एक सर्टेन अमाउंट तक अगर मॉइस्चर कंटेंट रहे तो वो अच्छा होता है, क्योंकि सी, इफ द मॉइस्चर वुड बी वेरी मच मोर. जस्ट आप सोचिए ना कि मिट्टी में अगर मैं ज्यादा पानी डाल दूं तो क्या होगा? मिट्टी गीला हो जाएगा. क्यों गीला हो जाएगा? क्योंकि हर एक पार्टिकल्स, द टू डिफरेंट डिफरेंट पार्टिकल्स, गैप जो है बहुत ज्यादा हो जाएगा, इंटर एटॉमिक गैप्स बहुत ज्यादा हो जाएगा, बहुत अलग अलग रहेंगे पार्टिकल्स, एंड हेंस द स्ट्रेंथ विल बी मोर लेस, राइट. तो सेम यहां पर भी होता है, ठीक है. तो ड्राई स्ट्रेंथ अगर आपका क्लियर है, तो हॉट स्ट्रेंथ नेक्स्ट चीज होता है. हॉट स्ट्रेंथ नेक्स्ट चीज इज हॉट स्ट्रेंथ. ओके, सिक्स्थ प्रॉपर्टी इज द hot strength. Now, what we have seen, for the green strength, it should have the ability of a green sand to retain the shape of the constructed material. So it should be in dry conditions. We have seen what is the meaning of dry condition. Now, if we talk about the hot strength, if we talk about the hot strength, so it is the ability of a molding material to retain the exact shape of the mold cavity at elevated temperature. See, what is the difference here? This is the difference as elevated temperature. If the molding sand can withstand its own configuration, can withstand its exact shape at elevated temperature, then at that point, that strength of the molding sand is known as hot strength, right? So let me write it very fast. It is the ability of the molding sand to retain the exact shape. Okay, so I think there is a cam there. To retain the exact shape of the mold cavity at an elevated temperature. At elevated temperature, please repeat dry sand. Dry sand is dry sand. Dry strength, I think you are telling about, right? See, in case of a dry strength, what is the thing? See here, it is the ability of a molding material to retain the exact shape in this dry condition. What is the meaning of this dry condition? When the molten metal is poured in the mold, right? When the molten metal is poured in the mold, so this is the dry condition. See, wet condition means what? Wet condition means there is a presence of moisture. Okay. Dry condition is what? When there is no presence of the moisture. See, earlier sand was having the moisture. Clear? Earlier sand is having the moisture, but when I am pouring the hot temperature liquid, so this as soon as this hot temperature liquid will get contact with the sand, whatever the moisture present in this sand will escape out, and that moisture place will now become the dry place, right? Will now become the dry place. So this is the dry strength is what? So at the dry condition, if the sand is able to maintain its shape and size, if the sand is able to maintain its configuration at this dry condition, and what is the meaning of dry condition? When the molten metal is poured, right? So if this is the thing, then that is known as dry strength. Then the molding sand is being told as, sir, molding sand का dry strength बहुत अच्छा है. समझ में आया? That is okay. Now, similarly, what is the hot strength? So it is the ability of molding sand to retain the exact shape of the mold cavity at an elevated temperature. बहुत ज्यादा टेम्परेचर जब हो जाता है तो उस समय पर भी वो क्लियर कर ले. तो सारा डाउट्स क्लियर है अभी तक सभी लोगों का? कोई प्रॉब्लम? सौरभ जी, should I proceed? Hot strength is clear. Should I proceed? हाउ मेनी टाइप्स ऑफ मोल्डिंग सैंड? मोल्डिंग सैंड्स का टाइप्स क्या होता है? टाइप नहीं बोल सकते हम उसको. मोल्डिंग सैंड एक मोल्डिंग सैंड होता है, ठीक है, एक तरह का सैंड होता है सर. उस सैंड में क्या होता है, कुछ बेस सैंड मिलाते हैं, ठीक है. बेस सैंड जैसे कि आपका जिरकॉन सैंड बोलते हैं उसको, क्रोमाइट सैंड बोलते हैं, ओलिवाइन सैंड बोलते हैं. लॉट ऑफ सैंड टाइप्स आर देयर, राइट? एंड इन दैट बेस सैंड we mix some binders we mix, and there is a moisture, so everything is called as molding sand, राइट? सो मोल्डिंग सैंड का टाइप्स भी मैंने कल आपको एक दो बताया था. फेसिंग सैंड्स क्या होता है, ग्रीन सैंड क्या बोलते हैं. सो वी विल सी दीज थिंग्स. ओके, वी विल सी दीज थिंग्स. Okay, so everybody is telling that everything is clear. So now next property is the adhesiveness. Adhesiveness. Now see, what is adhesiveness? So it is the ability of the molding sand to stick with the walls of molding box. Now it's very clear. By statement itself, it is clear कि sir molding sand has the ability that it should stick with the molding box, right? So suppose if this is the molding box, so with the molding box, the sand should have the ability to stick with this molding box, right? To stick with this molding box. Clear? So this is the adhesiveness. This is the adhesiveness. Now let's talk about the most important thing, sir. What is the most important thing? So we have seen the seventh property. The eighth property is collapsibility. Collapsibility. What is collapsibility? Sir, we have put the pattern. On that pattern, we have put the molding sand. After molding sand, we have ramming is done, and after that, what pattern has been taken out, mold cavity is there, we poured the molten metal, and once the molten metal is poured, it has been left to solidify. After the solidification, what? After the solidification, what? So you will break that molding sand, you will break that every mold cavity and mold sand part, you will try to collapse, right? You will try to collapse. Now what will happen if you are breaking this molding sand and it will not break? What will happen if you are trying to break this molding sand but it will not break? So what is the use of that molding sand if it will not break? Because if it will not break properly, then whatever the casting you have produced, you cannot take it out. If it will not break properly, whatever the casting you have produced, it will not take it out. So here comes a very very interesting and very much important property of it is molding sand, that ability it is the ability of molding sand it is the ability of molding sand to collapsed get collapsed after casting solidifies. Clear? Solidifies. So this is basically the collapsibility. And the last thing that we are going to see of this entire session, this is the last property, that is durability. Durability. And what is durability, sir? This is nothing. This is the ability. It is the ability of the molding sand to withstand repeated cycles of heating and cooling during casting operation. क्या बोलते हैं हम ड्यूरेबिलिटी को? क्या बोलते हैं सर? कि बोलते हैं ना कि भैया ये चीज कितना चलेगा, कितना लंबा जाएगा। इसका मतलब क्या बोलते हैं? इसका मतलब ये बोलते हैं कि व्हाट इज द ड्यूरेबिलिटी ऑफ दैट थिंग। सपोज इफ आई हैव अ माउस, आई विल से व्हाट इज द ड्यूरेबिलिटी ऑफ दिस माउस, है ना? कितना लंबा चलेगा, कितना लंबा चलेगा। So that is what is thing. So it is the ability of a molding sand to withstand repeated cycles of heating and cooling. So suppose you have made the casting, right? Again, after that, again you are using that sand. Again, if you are using that sand, so again if you are using that sand, or what, before the casting everything was in the cool condition, temperature was low. When you have poured the molten metal, the temperature becomes increase, so there is a heating case. So what we can see here, so there is a repeated cycles of heating as well as cooling, right? So repeated cycles of heating as well as cooling are there during the entire casting operations. So the molding sand should withstand with these kind of changes, and if molding sand can withstand these kind of changes, we can say that molding sand is durable. Sir, this was all about for today's session. If you have any doubt, then you can ask with me. If you have any doubt, then you can ask with me. I am most welcome. You are most welcome to ask the questions. And if you are planning for the plus subscription, then you should use my code SIRVK. You should use my code SIRVK. You should use my code SIRVK. That is SIRVK. You will get a 10% off, as well as I will help you throughout your preparation of GATE as well as ESE. Collapsibility, please एक बार और explain करें. What is collapsibility? See here. What is collapsibility? अगर 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 मैं क्या करूं, सुनिए सभी लोग ध्यान से सुनिए. मैंने क्या किया, मैंने पहले कैविटी बना लिया. ठीक है, कैविटी बन गई मेरी. कैविटी जैसे ही बन गई, मैंने मोल्टेन मेटल उसमें पोर कर दिया. जैसे ही मोल्टेन मेटल पोर कर दिया, तो मोल्टेन मेटल सॉलिडिफाई होगा. सॉलिडिफाई हो रहा है. जब वो सॉलिडिफाई हो गया, तो नेक्स्ट आप क्या करेंगे? नेक्स्ट तो आपका काम होगा ना कि जो आपका मोल्ड कैविटी जो बना हुआ, उस मोल्ड कैविटी को तोड़ दें. तोड़ के फिर उसके अंदर से तो निकलेगा हमारा कास्टिंग प्रोडक्ट. लेकिन क्या हो अगर वो मोल्डिंग कैविटी, वो जो मोल्ड आपका है, वो मोल्ड टूटे ही नहीं. मोल्ड टूटे ही नहीं, तो टूटना भी एक प्रॉपर्टी होता है. टूटना भी एक प्रॉपर्टी होता है. अगर मोल्ड टूटेगा ही नहीं, तो कास्टिंग कैसे निकलेगा? सो इट इज द एबिलिटी ऑफ मोल्डिंग सैंड टू गेट कोलैप्स्ड, राइट? टू गेट कोलैप्स्ड आफ्टर कास्टिंग सॉलिडिफाई. जब कास्टिंग हमारा सॉलिडिफाई कर जाए, तब वो मोल्डिंग सैंड जो है वो कोलैप्स करने का अगर उसमें क्षमता हो, तो उस क्षमता को बोलते हैं कोलैप्सिबिलिटी. ठीक है सर, समझ में आया? So you can always go for my code. Sir VK is my code. If you are planning for the plus subscription, use my code. If share this thing and see, the cost is 30,000. But if you use my code Sir VK, then you will get a 10% off, and that would be discounted amount would be 27,000. So Unacademy has a different plans: 1 month, 3 months, 6 months, and 12 months. So you can go for your subscription based upon your ease. सर कल का जो टाइमिंग होगा ना, फॉर एवरीबडी, आई विल बी टेकिंग द क्लास एट 9:30 AM. Strength of material will be at 9:30 AM for the 2 days, right? For tomorrow and day after tomorrow, 9:30 AM. Okay. So thank you so much for your active participation. I hope I was able to satisfy your thirst of knowledge. I was able to help you to understand these concepts. And thank you so much. Like my video, and if you have any doubt, feel free to comment in this section. Okay, I will try my level best to reply to everybody.